Hello everyone, welcome back to the channel. So in the previous video, what did we cover? We covered that if you have a certain array, how do you generate the power set of it? What do I mean by the power set? I mean, how do you generate all the possible subsets which are related to that particular array? So you see, this is the solution space for this particular problem. If I'm given this particular array, then these are all the possible subsets of size 0, size 1, size 2, 3 and 4 that I can generate from this. Right, so that is something which we saw in the previous video. We looked at how we can recursively write the code and what its time complexity going to be, what the space complexity going to be, what's the base case going to be, so on and so forth. So in this one, what we are going to do is we are going to solve our problem of the day for today based on the problem of subsets. And why I solved subsets first is because this is literally completely a variation of this particular problem. So if this concept is clear for you, this would be very easy. So let's have a look at what the problem statement says. Okay, it says the XOR total of an array is defined as the bitwise XOR of all its elements. So for example, if you have 1 and 3, the XOR total of 1 comma 3 is going to be 1 XOR 3. But what do we have to do? We don't just have to return the XOR total of the entire array. No, we have to return the sum of the XOR totals of all the possible subsets. So if you read the problem statement, that is what it says in very simple words. Return the sum of all XOR totals for every subset. Okay, so why did I cover the problem of subsets first? Because you see, you want to find out all the subsets first, then you are going to calculate what the XOR total is going to be, isn't it? First you find out the subsets, then you find out what the XOR total is going to be, isn't it? So if you think about it, you see over here, what did we have? We had 4 number of elements, right? If I had 3 elements, let's say 1, 2 and 3, then what would have been the power set for this? Empty. Then I would have had 1, 2 and 3. Then I would have had 1, 2, 1, 3 and 2, 3. And then similarly, I would have had 1, 2 and 3. Right. So these, since this is 3, 3 sides of 2 to the power 3 is equals to 8 total possible combinations. That is exactly what I have over here as well. You see 5, 1, 6, 5, 1, 5, 6, 1, 6 and then 5, 1, 6. After calculating all the possible subsets, what do? You calculate the XOR total of all of them. So you see, in the previous problem that we did, in the subsets problem that we did, what did we do after calculating all the possible subsets? We, sort of we pushed all of these states. So this particular state, this particular state, this particular state in a 2D array. So I put all of these states in a box and I returned this box as my answer. Now I don't actually have to push these arrays inside a box. What I have to do is calculate the XOR total of these boxes. So whatever the XOR total of this array is, I calculate. Of this, of this particular array, the XOR total is 6. And then all these XOR totals, what do I do with them? I add them all up and then I return 28 as my answer. You see, so again the same thing, just very 2 simple steps. Generate all possible subsets. Okay, so you generate all possible subsets, and when you reach the base case, only the base case is going to be different. You see, at the base case, previously you were pushing them in a box. Now what you have to do is calculate the XOR total, and you have multiple choices. Either you can maintain a global answer variable and add whatever the XOR of this is to this particular global variable and ultimately return this, or what you can do is you can return the XOR total of this. Let's say this is 10, this is 20. You can return the sum of both of these to this particular state let's say this is 40, so you return the sum of them to this particular state, and whatever comes from here, let's say 10, you return 70 plus 10, overall 80. So again, whatever you choose, it's completely a matter of choice. Over here, what I have done is, you see, again the same logic, copy paste logic. You take and explore, you do not take and explore. Okay, but the only thing which is different is the base case. So as soon as my index is out of bound, what do I do? You see, I calculate the XOR total. And over here, what I have done is I have taken a global answer variable. I calculate the XOR total of my current array, of my current state, whatever my current state is. So the current state can be this, it could be this, it could be this, it could be this, it could be anyone. So what I do is I calculate the XOR total of that particular array. So if it's empty, if current dot size is 0, then obviously add is also going to be 0. If it's greater than, if the size is greater than 1, then I calculate the XOR total like this. So I keep on, this is equals to this, in very simple words, is equals to this. So add is equals to add XOR current of I. Okay, means the same thing. So if I run this code, let's see if it passes all the test cases. Okay, let's see if it passes. Okay, it does. It does, but you could have very well done it in the other manner as well, right? You could have made this function an integer. Let's actually experiment with that. Let's actually make this as an integer, and rather than doing this, what I'll do is I will return the add from each and every state. So this is going to be when I take something, this is going to be when I don't take something. So take and explore, not take and explore. And what do I return after I have explored take and not take? After I have explored both of these, I return the sum to the previous state. So what I'm going to do is just this, return take plus not. So if I submit this code even, it's going to hopefully pass all the test cases, right? It does not. Why? What's wrong? Oh, what's wrong is that I'm not actually capturing the, I'm returning answer. Answer is 0 over here. So what I should actually do is something like this. Answer is going to be this, right? Whatever solve returns for me. So if I run this particular code, it's going to pass all the test cases, and it's ultimately going to pass all the hidden test cases as well. So again, the very same time complexity, O of 2 to the power n, and think about how much extra space you are taking. Okay, so again, what did we learn from today's problem of the day is that if you know the root problems, you see, if you know the root problems, then solving the variation becomes very easy. You see, if you knew how to calculate subsets, this was a piece of cake. This wasn't a hard problem at all. But for this to be solved, you needed to have the prerequisite knowledge of how to calculate all the subsets. Okay, so my advice would be that always first, if you're starting your problem solving journey, always initially in the initial 1, 2, 3 or 4 months, think about the root problems, master them. Okay, so I hope the video was useful, and I'll see you in the next one.